Now it's time to start with Matteo Romano.
Okay, good. So I'm presenting this project on new fuels from biogas and CO2-rich natural gas that I am supervising with Carlo Visconti. And you see also the name of Riccardo Rinaldi, who is the victim that we selected to do the hard work in this project. So what are the motivations for this project? Is first one, some boundary conditions that we expect for the next decades. First one is that the value of the avoided CO2 is expected to rise significantly in the coming decades, which means that emitting CO2 will be expensive and avoiding CO2 emissions will be a valuable action. So the value of biogenic carbon also expected to increase significantly, including the CO2 generated in small, medium-scale plants, for example, biodigesters, so biogas plants. So also these leakages of CO2 should be avoided in the medium-long run. Also, we expect electrification of the economy that will require the increase of coupling between sectors. We could expect that R&D efforts on electrolyzers will drive down the cost of electrolyzers significantly. So basically, we are relying on Hubert's work, reducing the content of iridium in electrolyzer. And also that intermittent operation of electrolysis systems is likely to be needed, at least initially, depending on the fluctuation price of electricity. So the objectives of our project are these two main objectives, is to assess different routes for converting methane CO2 mixtures and intermittent hydrogen into liquid fuels. And secondly, to assess the potential of novel, low technology readiness level technologies, so emerging technologies, in this application, in application that must be flexible. So to give just one example of one of the possible systems, actually the first one we are now assessing is this one. So you start with a conventional anaerobic digestion unit producing biogas to be cleaned, conditioned by means of separating CO2. Could do reforming, steam reforming out of it, and then you synthesize the product, in this case methanol. So the system here should be tuned to achieve tuned means removed, the CO2 should be removed in a correct amount so that at the inlet of the methanol synthesis unit you have a module of two, which is that equation. But we also have an electrolyzer, so we will have intermittent electricity. Depending on the electricity price, electrolyzer will be switched on or switched off, so you will have intermittent hydrogen fed to the unit. Therefore, depending on whether you have the electrolyzer on or off, you will need to tune the amount of CO2 removed by the biogas stream in order to achieve always a tailored composition module equal to 2 at the inlet of the methanol synthesis unit. So the research question for this type of systems are fundamentally two, I think. Well, first is how to design and how to operate a plant that should work flexibly in this way, capable of operating in 2 operating points at least. Secondly, what is the potential of new technologies in working in systems like this? This project is supervised by, I said, me and Carlo. I am part of the group of energy conversion systems, which is a process engineering group mainly. We have a solid background in process simulation, techno-economic analysis and comparison between different technologies, hydrogen production technologies, CO2 separation technologies, heat recovery, power generation cycles, or in general, heat integration. We have some projects running in this area. 2 of them are European projects that we lead as group. We are coordinator of these projects. One already includes the flexibility issue, so working with biofuels production, in that case DME, but it's just a detail. It's a system to be operated flexibly, another one on methanol production with novel technologies. And then we have experience within our group on the modeling of mid-long-term systems integration scenarios. Carlo belongs to the Laboratory of Catalysis and Catalytic Processes Group, LCCP, which is a group experienced in development of heterogeneous catalysis for energy and environment, engineering intensified catalytic reactors, novel catalytic processes, tests and modeling of catalytic technologies, including CO2, hydrogenation, and synthesis, production of synthesis fuels. And there are also ongoing projects in this area, some of them from companies, like with Eni, Tecnimont, or with the Research Center, Enea, or again with the European project FLEDGE, where we nicely already work together. So methods, in very few words. First, we are going to develop process models for flexible biogas plus intermittent hydrogen to liquid plants. We're going to develop models for the economic analysis of these plants, and we'll go then into more details with the modeling of some of the what we'll identify as key reactors for these processes.